Hey, what's going on, folks? Today I'm going to do some lecturing on temperature, and hopefully this all works out for you. So check this out. Some equations, relevant equations I think we're going to use is basically T of, come on buddy, give me a brush, paintbrush here. T of K is equal to T of C plus 273.15. And really what this is it's the idea of converting between Kelvin temperature, named after Lord Kelvin, and the centigrade temperature, also known as Celsius. And I'll make a vice versa arrow so it goes from Kelvin to Celsius or from Celsius to Kelvin. You basically just move that 273.15 over to the left side by subtracting it or adding it on the right side. Okay, and then the other one is between Fahrenheit and Celsius. So I think the one I remembered back when I was a kid was temperature in Fahrenheit is equal to the temperature in Celsius times 9/5 plus 32. All right, so this would be Fahrenheit, Fahrenheit to and from Celsius. And you can move this equation around if you want to, solve for different things. All right, let's try a few things, and I have my calculator right next to me, and we'll get this party started. So the normal body temperature is 98.6 degrees Fahrenheit. Well, that's normal for us people in America who use a dumb measurement like Fahrenheit. What is the rest of the world using? Because they would measure things in Celsius. All right. So all you would do is if you want to get the Fahrenheit and you want to solve for Celsius, I would use this equation right here. We'll call this equation number 1, and we'll call this equation number 2. And give me a second. Sorry, my computer is just freezing up today, man. There we go. All right. So this is equation number 1 and number 2. So I guess I'm using equation number 2. So this says T of Fahrenheit is equal to 9/5 Tc plus 32. If I want to solve for Tc, I need to subtract 32 from both sides. So I've got T of F minus 32 equals 9/5 T of C. And then I'm going to multiply by 5. I get 5 times 32, or 5 times T of F minus 32 equals 9 times Tc. And I'll divide by Tc, and I get Tc, or divide by 9, and I get Tc equals 5. Oh, I'm screwing this up. 1 second. Give me a second. Just let me back arrow that back. All right, I'll just scratch it out. It's equal to 5. Come on, buddy. Come on, computer. There we go. All right. So it's equal to 5 times Tf minus 32, all divided by 9. All right, and we said Tf was 98.6. So all you got to do is plug and chug at this point. So Tc is equal to, let me use my handy dandy calculator. Okay, and let's go. 5 times, parentheses, 98.6 minus 32 divided by 9. And I get 37 degrees centigrade. Now, 37 degrees centigrade, if I want to convert it to Kelvin, and that's the second part of the question, so what is TK? Well, all it is it's whatever Tc is plus 273.15. So I can just simply go, all right, fine, that's 37 plus 273.15, and that's equal to 310.15. There we go. That's it. And I'm done. Cool? All right, let's talk really quick about significant figures. And to be honest with you, I think I think that the best way to do significant figures in this particular case is to say, well, this one should be 37.0 degrees Celsius. And this one over here, I'm going to make that 3.10 times 10 to the second power degrees Kelvin. Actually, I don't think we use the degrees symbol when we talk about Kelvin. I don't know why. But anyway. The reason being is because the difference between the Celsius and the Kelvin, well, the reason why I made one scientific notation, the other one not, is because, well, let me show you this. The problem gave us three significant figures, the 9, the 8, and the 6. So my answer should have about three significant figures. So that has three significant figures. If I wanted to write that in scientific notation and have three significant figures, I could easily do this, 3.70 times 10 to the first power degrees Celsius. Because that times 10 to the first power moves that decimal place down one to the right, and you have 37 degrees Celsius. Over here, this is 3.10. That is three significant figures, and it's times 10 to the second power because really the answer is 310. Cool? Cool. All right, let's do this one. Let's see. One interesting feature about Celsius and Fahrenheit scales is that negative 40 degrees Celsius and negative 40 degrees Fahrenheit represent the same temperature. So, verify that this is true. All right, fine. Here's what I'll do. I will say, let me try this. I'm not sure how I'm going to approach this. Let me just write the equation down. Temperature Fahrenheit is equal to temperature in Celsius times 9/5 plus 32. All right, that's my general equation. So here's what I would do. I would honestly just say, all right, fine. If I plug in negative 40 degrees here, then what I should get is my answer should be negative 40. And I can verify that this is true. So, negative 40 times 9/5 plus 32. Okay, so negative 40 times 9 divided by 5. That's negative 72 plus 32. And this is TF. All right, plus 32 equals negative 40. Interesting. Degrees Fahrenheit. Awesome. Okay, some thoughts about this. Well, it's because I can tell you why this happens, and the answer is it's because the size of the markings, the size of the markings between centigrade and Fahrenheit aren't the same. So it's kind of like the difference between inches and centimeters. The inches are just bigger, and the centimeters are much smaller. So you're going to have some weird properties like this when you have two different rulers that you're using. In this case, the centimeter, the inches is actually, and this is kind of weird, but the inches is kind of like the centigrade because the units between the centigrade is much bigger than the units between Fahrenheit. All right, let's do another one. The last one I'm going to do is liquid nitrogen. Let me just, come on, scroll down for me. There we go. All right. Liquid nitrogen is often used as a coolant for low temperature experiments. It has a boiling point of only 77 Kelvin. And no, I don't think we say degrees Kelvin. But what is this temperature in Fahrenheit? All right, cool. I'll give you the idea, the plan here. I'm going to go from Kelvin, I'm going to convert it to Celsius. And then from Celsius, I have a nice equation to convert to Fahrenheit. All right. So Kelvin's pretty easy to convert to Celsius if I have this. I know that TK equals TC plus 273.15. So if I want to figure out what TC is, that's equal to TK minus 273.15. All I did was I subtracted 273.15 and put it on that side. And then I switched it around because, you know, I like having the thing that I solved for come first. All right, so that would be the temperature in Celsius is equal to 77 minus 273.15. 77 minus 273.15 using the calculator gives me negative 196.15. Got it. Then what I'm going to do is I'm going to simply, let's see, take this and plug it into my equation. TF equals TC times 9/5 plus 32. Actually, you know what? I don't like writing it like that. I'm going to write it like this. TF equals 9/5 times TC. It doesn't make a difference really, but I always like having my numbers in front of my letters. So plugging this in, I've got TF equals 9/5 times negative 196.15 plus 32. All right. Okay, ready? 9 times 5, or 9 divided by 5 times 196.15 plus 32. I get negative 321. TF is equal to negative 321.07. But I don't want to be an idiot and just put down a whole bunch of numbers. I actually probably want to use only two significant figures, because if you look at the problem, they only gave us two significant figures to begin with. So my answer is negative 3.2 times 10 squared. Or I guess if you want, oh, and by the way, this is degrees Fahrenheit. Or I guess if you want, you can make it negative 320 degrees Fahrenheit. These mean the same thing, but anyway, that's the difference. All right, folks, hopefully that helped you out. I'll shoot up a few more examples for you, and maybe as we go through these, this might actually make more sense to you.